So we'll start 3-1 and do probably 3-2. See how we feel at that point. What's it called? Have you guys had time to watch the videos on derivatives, or what is a derivative? But to keep it up simple for now, we're going to be talking about derivatives the rest of the semester. Pretty much, we talked about the limit just so we can define the derivative. So what it does for you is it gives you the slopes at any given point. So if I choose, let's say I choose this point right here, and I drew a line right next to it. Let's see what I draw a line. Use my right hand. That's so imagine there's a point right there. So the line tangent to that point has a slope. So I guess picture this. As we go up, left, right, increasing. So all the slopes are positive. Get to the center point and it's horizontal, so constant. So depending on the function, slopes are downward or negative. So derivatives will tell you the slope or the rate of change that you function for something in real life like true growth, right? You can find rates of change different. So if you had like, let's say position, right? You had a function that says given a time will tell you where you are, assuming you're going in a certain direction. So the derivative will tell you the rate that you're moving, which would be velocity. Another derivative of that second function. So each time you do one, you find another function. If you took two derivatives, velocity would then become acceleration because that would be the rate of change of velocity. Rate of change of position would be sorry. Rate of change of position is velocity. Rate of change of velocity is acceleration. Okay. So that's what derivatives are. I'll show you how to find them in a moment, but basically they tell you about rates. On a graph, they tell you about slopes, which are rates, right? So if you have, let's say, I don't know, let's say you had clear drawings. A parabola. From left to right, all the slopes over here are negative. But then that's when you get to the apex here, or the valley, it's constant. And then as you increase, the slopes will all be positive. Okay, so we're going to start finding the derivative. We're going to use, first of all, limits to find it. And then we'll show you the shortcuts, which I prefer that you use in 3-2, 3-3, etc. There will be one question doing the long way, but that's it. In exam 2. That's quite a ways away from now. So anyway, let's start 3-1. Just a brief idea as to what's happening. Okay. Look at the homework really quick, make sure there's nothing strange in there. Okay, number 1. They want you to find the slope of the tangent line. So remember I drew in the graph that little line. So they want to know the slope at this specific point right here. So you're going to find a derivative, plug in the x, and the derivative, what it does for you is give you slopes at different points. So if it's negative, then we're decreasing. If it's positive, we're increasing. That's all it does. So we're going to learn how to find it, and then later we'll learn how to use it. The slope of tangent line, all that is the slope at that point tangent to the function. Okay. So let's learn how to do that in just a moment. So the first few questions. Yeah, let's see. Delete that. So the first two would just be find the derivative, plug in the point. Find the derivative, plug in x. When you find it, the function will give you this slope 18. This one gives you 4/7. Number 3 is something you should, from the videos, it said the derivative of any constant function is 0 because a constant function is constant. So f equal to a number is a constant function. It's just a horizontal line. So there is no rates of change. So the derivative would be 0 because it's not changing. Okay. Anyway, here they use the limit process, which is what we're going to do in just a minute, to find the derivative of f again and again. Okay. Anyway, problems. It's fine. I think these are fine. Okay, so let's get started. Let's do example. Example 2, I guess. Just a moment. Okay, so the derivative. And the tangent line. Find the derivative using limits. So this is the only section we're going to use limits to find them. After that, we'll do shortcuts. Turn off these notifications. People keep bothering me today. Yes. Yes. Well, I guess let me try to explain a little bit simply. It's many different things. It's a lot of stuff, but basically, the idea, right? Forget. So, do you remember how to find slope? Right, so let's say we have some function f, right? Always turns off on me. Some function f, and I have, let's say, a point here, x1, y1, or yeah, y1. Another point there, x2, y2. Okay. So if we found the derivative, or I'm sorry, the slope that connects those 2 points, slope between those 2 points, right? It'll be here, right? Some line there. But you see, as the line starts to curve, picking 2 other points, it's not going to give you the exact rate because it's curving, right? So the derivative is the slope at one given point. So what you end up doing theoretically is you shrink the distance between 2 points. You let that distance go to 0. So instead of finding the slope of 2 points, you find the slope of 1 point, which gives you the rate of a function at any given spot you want. That's why we cared about limits. That's why we studied them. It's just so we can basically change the x1, x2, let it go to 0. So that, yes.
It's so would be accurate to say a derivative is the slope at one point of a function.
At a point tangent to the function. So yeah, basically. So in general terms, yeah, that's what it is. Okay, so you shrink it down, giving you a slope. Okay. So the derivative of f of x is equal to the limit of f of x of x plus h minus f of x over h. So you're allowing h to go to 0. So this is like an alternate form, or the slope of the secant line back in college algebra a while back. So we're trying to shrink that distance between x1 and x2. So we're letting it go to 0, meaning we're letting them be equal. And if they're equal, that is a single point, right? It's not 2 points anymore. That's why we're letting it go to 0. So using this, you end up finding that. I'll put it right here, f prime. So that's what we're going to denote as the derivative. Okay. All right. So, example 1. I think this is problem 2, yeah. From your homework. Find the slope of the tangent line. It's also called the instantaneous rate of change, the derivative, by the way. Instead of a average rate of change. You remember finding the averages of that in college algebra? Yeah, it was like it would be basically the slope. If you have this function here, if I wanted to find the average between this point and that point, you would basically use the slope form. So now this idea is an instantaneous rate, not an average rate. It's at one spot. Okay, so it's like finding out how fast you're going at 6 seconds versus how fast you're going on average between 0 to 6 or something. Anyway, so here's f of x that they give us. I don't think I have enough space here, but oh well. 3x squared minus 6 at, so they want the rate of change, basically. That's what they're asking at this point, 3 comma 21. So here's the function. There's a rate that we're going at 3 comma 21. It's another way to think about it. That's what the slope of the tangent line is. It's the rate of change, instantaneous rate of change at 3. So you need to find the derivative. So f prime, in other words, the derivative, is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Okay. So this should look familiar. Remember doing this at some point? A long time ago. Okay. So let's just plug in x plus h into here, subtract the original, and then divide by h, see what happens, and then the final step, take the limit. We can't take the limit at the beginning because it will cause division by 0. So we'll get 3 times x plus h squared minus 6 minus 3x squared minus 6. That's this part, right? Now that's this one here. Anyway, divided by h. That will equal let's just finish this on the next page. 3 times x squared plus 2xh plus h squared minus 6 minus 3x squared plus 6 minus minus. Still with me on the algebra? Where did I lose you? Here? Okay, so we're applying this formula, right? So x plus h goes inside the f. F is this guy. So that's why it's in here, right? Minus f, so that's just minus the original. So then we go to the next step, distribute the minus, so minus and plus. This must be expanded. You have to FOIL, or however you want to think about it, multiply. Multiplying this twice gives you these 3 terms. I skipped the multiplication step here. When you do the FOIL, you're going to get that. And now we have to distribute the 3. 6 is the count. All right. Oh, wait a sec. While I turn the page. Anyone else have questions on this algebra? You guys good on this page? Okay. All right then. So we still got to write the limit the whole time. So we got x squared plus 2xh plus h squared plus, what was it again? 3x squared
3x, no, minus 3x squared.
minus? Thanks. Almost got it. Well, okay. Distribute the 3, see what cancels, and then factor h. The h's are supposed, this h down here is supposed to cancel. If it does not cancel, then you made a mistake somewhere. When you're doing this in the homework or an exam, h needs to cancel, and then you take the limit.
I got this all the way down to 6x plus 6h.
Sounds right.
Okay.
Let's see. To distribute the 3 times x, 3 times 2, 3 times 8 should be a 3. So this is gone. So at this point, notice we can factor, right? You see. Factor the top and cancel. Then you can take your limit finally. H's are gone. So you can take your limit. I can stop writing this damn thing. Once you take it, you stop writing. H goes to 0. Answer is 6x. So this is the derivative. So f prime is equal to 6x. So this function is going to tell us the slopes at any given point that will be tangent to the original function f. It's pretty cool. I think I had different numbers.
So we're just looking for what's not h, right?
Yeah, h will go, well, we're trying to cancel this h. It's going to cancel every single time.
Plus 3h.
You take the limit finally, you let h go to 0. So you take the limit once you're able to, which will happen once you cancel the h on the bottom. Kind of like a removable. Okay, so what was the question? Because that was a while ago, right? Page 1, it was find the slope of the tangent line. So at 321. So all you got to do is plug in 3 into the derivative. That's equal to 18, which is the slope, or we can call n tangent. So if f was like modeling some sort of growth, and you want to know what's happening at, let's say it's in days or seconds or hours. So I want to know what's happening in 3 hours. You plug in 3 and you have the rate of growth at that time. Rate of acceleration, rate of velocity, whatever. Any questions on this idea?
And the answer is actually 18.
Yeah, that's all I wanted. 18. Just need to make sure you understand what does that 18 mean, right? That's more important. Yeah, same numbers. Okay. You guys pulling this page? So let me give you all the shortcuts. I don't want you doing that method every single time. I just want you to know how to do it at least once. Just one time. So shortcuts here for derivatives. The derivative of any constant is 0. So if your function is equal to some c, where c is an element of the real numbers, f prime is 0. So that's just called the constant rule, or derivative of any constant. So if you have a number, derivative is always 0. Doesn't matter what number it is. It's pi, a fraction, a decimal, a negative. Who cares? It's going to be 0. Power rule. So if you have a power function, x to some n power, where n is the element of the real numbers, and make the fancy R, just make a capital R. F prime will be n times x to the n minus 1. So all you have to do is you take that power in front, and then you subtract 1 from the original power. That's all you gotta do. Okay. One more rule. Our rule, I guess, extended. Let's say you had a number in front, 2x. Well, let's use a variable. Let's say you had c x to the n. F prime will simply be c times n times x to the n minus 1. So you just bring it down and you multiply. Okay. So if we were to redo example 1, using these methods, you'll see we'll get the same thing. So RF was equal to 3x squared minus 6, right? At 321, I think. Yeah. Yeah. Okay. Thanks. Okay. So if we use the rules, oh, and the instruction said find slope. Slope of the tangent line. So the derivative will be, right, you bring the 2 down, subtract 1 from the 2. Derivative of a constant is 0, so it's gone. So you do derivative of this piece first. Bring down the 2, subtract 1. Derivative of the constant, 0. So our answer is 6x, which is what we got earlier, right? Using the long method, the limit process. So again, on the exam, I'm only going to make you do the limit process once. So practice it a little bit, but focus on learning this technique. Okay. Okay. Any questions on these rules? And do you see how it's the same thing? So as the functions get more complex, we'll have more and more derivative rules. The limit process can do it for any function right now without needing any special rules. So there is an advantage there, I guess. But as we go through chapter 3, we'll learn all the techniques. So we'll have all the shortcuts, basically. So we won't need the limit anymore. Move on. But you're going to see in the homework, there's a couple that you have to use limit rule because we haven't learned all the techniques. If you look 1 through 5, you can use the shortcut, no problem. 6, 7 cannot, because we haven't talked about fraction type or square root types. So you can't. You have to do a limit process here. The rest, it looks like you can. Step 12. Oh no, there's some more square root stuff. 12, 13, you can't. For the most part, you can though. I'd say about 60%. You can use the shortcut. 3.1. Let's do another one. Let's do example 5 using the shortcut method. You guys cool on this page? Any questions on this? Does it make sense? That's right. Okay. I'm going to turn the page. Is that cool? Example. I guess 3 technically. Problem 5. All they're asking for you to do is find the derivative. Every time I say derivative, you take a shot. Get it. Find the derivative of this guy. And we'd all be dead, man. Plus 4x squared. Okay. So use the power rule and just keep in mind we got those numbers in front. So the derivative will be, do it term by term. First term, bring down the 3, right? And then you subtract 1 from the 3. Next term, you bring down that 2. Subtract 1 from the 2. So we will get 6x squared plus 8x. You agree? Using the power rule. That's all they wanted. They didn't ask about slopes, but we have the derivative if we wanted to find them. I think that's what they got. Let's see. Yeah, there it is. So 3, 4, 5, 6. They just want you to find the derivative, and that's it. Remember that 6 and 7 will require limit process. Yes.
Because honestly, if I look at 6x squared plus 8x, it kind of feels like there's more I can do. I don't really know how to explain that, but that's what I'm gonna think.
I mean, we could do all kinds of things we want, do whatever we want, right? But
Like,
what do they ask for?
Like, it feels like it's not done, is what I'm saying. I don't know if it's done.
They asked for one derivative and we did one. So we just let it go. They didn't ask for anything else. There's no like terms or simplification to do, right? So we're good. This guy right here is a derivative of f. I mean, you can take as many derivatives as you want, but they didn't ask for it. You could take second, thirds, and fourths, but they just wanted one, and that's fine. But they can't ask all kinds of stuff if they wanted to. Like they could have asked about the slope or other stuff. But I'm not sure what's bugging you though.
If there's no power, but there's like the actual equation, you technically use one as a power.
Yeah.
Oh.
Yeah, if you follow the same rules, right? Like if you had a, I don't know, let's say we had, let's make one up for you. Find f prime. Not on the screen. Cool. Let's say f is 2x, right? Something like that. F prime will be 2, bring down the 1 because there's a 1 there. Subtract 1. So now we have 2 times x to the 0. Anything to the 0 is 1. No more x. So every time you take a derivative of a power function, you lose a degree. So if we start with a linear function, one derivative will take us to a constant function. We start with a quadratic, we'll go to a linear, etc. Some functions have infinite number of derivatives. As you can see, the power functions do not. Eventually they go to 0, right? They keep reducing from like that guy on top, it'll go 3, 2, 1, then it'll be gone. I guess it'd be 0 and then gone. Okay. Do you remember how to find the equation of a line? Given, remember back in, when was that? I guess that was a long time ago.
y2 minus y1 over x2 minus.
Yeah, we would use that to find slope. And then we have another equation. We'd use that y equals mx plus b, or we'd use the point slope, those two different ones. And we would find line equations given like a 2 points or some sort of information. So notice how on question, let's see, question 7, they want the equation of the tangent line, not just the slope. So you're gonna have to find the derivative, plug in that point to get the slope. Once you have a slope, you can find, once you have a slope and a point, you can find a line of it, or you can find a line no problem. That's back what's it first taught? Like 9th grade, I think. It's a long time ago. Long time ago. May have seen it rehashed in college algebra or anything before that. Maybe. So let's talk about it again, because we're going to need it for the last few problems here. That looks stupid. I'll get rid of that one. Okay. It's fine, I guess. Okay. Let's do an easier one first, because I don't want to get you bogged down by algebra. Let's first understand how do we do it before we start doing fancy stuff. Okay. Before we move on, you guys cool on 3 and 4 though? Okay. So let's revisit question 1 again. I'm going to change the example, whatever we are. Example 5. Create a new question. This time, instead of finding the slope, find the equation. Of the tangent line. We have was what, 321, right? Question 1. Given an f that was 3x squared minus 6. So let's skip all the steps that we've already done. We've done them twice now. For the same question. So the derivative we found. Let me write the function again. F was this guy. The derivative was this, right? The m tangent was f derivative at 3, which was 18, correct? We did all that stuff earlier, twice. So now we're going to revisit, how do we find lines? So we have all the information to do it, we just got to remember how to do it. So the best way that I recommend to you is to use the point slope formula. To find the equation of a line, I mean of any line. In this case, we're doing a tangent line, but it's still a line, so who cares? Okay, so it's going to be y minus y1 equal to m times x minus x1. Use m10 and 321. See where we are going with this, right? So this guy will give you the line equation. We already got the slope and we got a point, so we are technically good. Yes, or stretch. Okay. Any questions so far? So plug it all in. Y minus 21 equals to 18 times x minus 3. Isolate dy in just a moment. Distribute the 18. What's 3 times 18? 54. Let's see, 3 times 18.
54.
So now add the 21 over. What is negative 54 plus 21? Will be negative 33, right? So this is it. This is the tangent line. In a moment, I'm going to graphics so you can visually see what the heck that is. But does the work make sense? So if they ask you to find the slope, well, take a derivative, plug in a number. If they ask for the equation of a line, well, you need a slope and you need a point, so it's an extra step. If all they ask is for a derivative, then great, we can stop at step 1, right at the beginning. Okay, let's graph it. What does this nonsense look like? So we have a function. 3 3x squared minus 6. Then we found this tangent line. Well, first let's plug the point. 21. So there's the point that they're curious about, right? Now the line tangent to that point, we found it to be 18x. So the line right tangent to the point that goes through the point, sort of. So at that specific point on the parabola, we have a line tangent to it. Okay. So the slope of that line is the rate at that point. Hard to see. Wish it was a little to the right, but anyway. Any questions on this? Does this make sense? So that's the main things are the 3 main things they're going to ask. Put the questions back. They're going to ask first, slope of the tangent line. Slope of the tangent line is the first thing, and then just find the derivatives. Use whatever method you want. I don't care. Then you get to questions like this where they want the equation of the tangent line. Then they start to get a little weird, I guess. They say find an equation of a line that is tangent to the graph and parallel to this random line. Just to test you even more on your knowledge of lines, graphing lines. I'm not going to test you on that kind of stuff, but it is in the homework. I do expect you to do it. It'll be good practice to refresh you on lines. Do you remember what it means to be parallel?
It runs along with it.
Yeah,
Doesn't touch.
yeah, they never touch. They have the same slope, right? They have to have the same slope, otherwise they'll be growing at different rates and they'll intersect somewhere, right? Some point. I don't know where, but somewhere. But if the slopes are the same, then the lines will never intersect. unless they are the same line, which is stupid. Okay. So basically what you got to do for number 8, which we'll do together in just a moment, is find the equation of the tangent line. And then oh, I see. Okay. It is tangent to the graph, parallel to the line. So they did not give us a point. The first thing we got to do is solve for y on that random line that they gave us. Once we solve for y, we will know the slope and the intercept, right? So that means we can find the slope without doing any work, or without doing any calculus, I guess I should say. Find the slope by doing algebra. Once we have the slope, we can plug that into the original to find the point. And we can do like we did last time, because we'd actually have a point, because the last few questions they gave us an actual location, right? Here they did not. So we kind of have to infer what the point is. Coordinate, not the point. Coordinate. By using the slope. That makes sense? It's kind of weird. It's like word to use, but anyway, let's move on and let's try it out. I won't say fundamental, but really testing our memory on this one. Example number 6. Find the equation of the line tangent to the graph of f and parallel to the given line. X minus y plus 1, 0. All right. So first thing, solve for y. First thing. All right. If you solve for y, that'll be what? Y equals right. Move the 2x and 1 over. Divide by -1, and we're good. M is 2. Right. Once it's in slope intercept form, you can just look at the slope, right? Remember that? It's an mx plus b mode, so I can see the m. All right, so if I plug in that 2 into f, I will have the point that I need to find the tangent line. So this gives us 2, 4. x1, y1. Use m equal to 2 and 2 comma 4 to find the tangent line. Is tangent to f of x, right? That's why we plugged it into f. That's why it's called tangent. So here we go. Y minus y1 equals to m times x minus x1. So that'll be y minus 4 equal to 2 times x minus 2. Plug in all the garbage that we know. Solve for y, and we'll have the tangent line. And that better be parallel to the one he gave us, right? Otherwise, all this is nonsense. Y minus 4 is equal to 2x minus 4. Solve for y, and we will get 2x, correct? Yeah, I'm skipping some minor algebra steps. If that messes with you, let me know. This is the tangent line. Okay. Is it parallel to the one they gave us?
Have to graph it and double check.
We can. But as long as they have the same slope, they will be. This has a slope of what?
2.
And what about this one? Yeah. So we got y equal 2x plus 1 and y equal 2x. We have two parallel lines. One is a tangent line, which is the green one, and the other is the blue line. Okay. So it was a little difficult to see, to approach it, unless you know what, you kind of have to read between the lines on that question, which is why I don't think it's a good test question. It's a decent homework problem. But you had to look at it and say, okay, well, parallel means that my tangent line has to have a slope 2. So now I automatically have 2 because that's what I'm going to get from solving for y here, right? Then the next thing I'm like, okay, well, to find the equation, I need a point, and I was not given a point. So that means I got to find the point by plugging in the slope into f, because if I plug in any number, I'm going to get a y value, right? So then I have a point, I have a slope, I'm good. You can use your formula. But that wasn't obvious, yeah.
The only thing that really matters for the answer, because honestly, I spend more time trying to format the answers correctly, is this making sure that the slope is right, because 2x minus 1 doesn't really fit in there. Unless you're just considering the slope.
Where did the -1 come from?
-1. Let's see. Now, let me double check my algebra here. We subtract 2x, subtract 1, they should both be negative. They gave us a minus divided by negative, they should all be positive. Okay, this line is fine. F was that guy. Plugging in 2 into the parabola gave me a 4. y1 was 4, x1 was 2, slope was 2, no negatives, okay. 2x negative 4 plus 4 plus 4. Well, I mean, that is another parallel line, but it's not our parallel line. We gotta plug into the original and get a value. Plug in the slope. Let's see what they did. Maybe I forgot something. Oh, I see. Well, we got 2, right? We plugged in 2 here, and we plugged in 4. Well, their numbers are different for this one. The work, they said the derivative equal to that number and solve for x. I mean, I see what they did, but I'm wondering why my method did not work. They set the derivative equal to the slope. So we should have done 2x equal to 2. Oh, I see. Okay. So let's see here. My mistake came in there. I made an assumption that I can plug this guy in here to find the y value. But that's not true. At this point, it's BS. I cannot use the 2. Which means that everything below this line is also BS. We found the parallel line, but not the parallel tangent line. That's where we went wrong. So we need the derivative after all, which will give us 2x, right? Then we set the derivative equal to the slope, which we found here. X will be 1. You plug in 1, which gives us 1. So the value, the point we're supposed to use is 1, 1, not 2, 4. Okay. So we did have to use a derivative to help us a little bit. I thought you could avoid it, but I was wrong. But all the work and the steps are the same. The only thing that changed was how you find x1 and y1. Everything else is the same. Okay, because I found the line, but it wasn't the right line. So plug in everything again. Y minus 1 equal to 2 times x minus 1. Y equals to 2x minus 2 plus 1. So that would give us the one they wanted. Here. Sorry about that, guys. Anyway, that caused any confusion for you? Anything, did I lose you anywhere? Is this okay? Okay. Well, that's pretty much 3.1. So let's, yes. Oh, I'm not changing it yet. So main thing you gotta watch out for is, can you find the slope of the tangent line? Can you find the equation of a tangent line? Can you take a derivative? And then can you do these weird problems where you gotta find a tangent line that's parallel to another line, a random line? Those are the main things you gotta do. I mean, they're all very similar. Some of them just have extra steps or less steps. They keep coming down to derivatives and slopes. .2 is pretty chill. It's basically learning how to do the power rule over and over again. Since we learned it earlier, that section will be much more easier. Got any questions on 3.1? So,
Why are X and Y both one again? I got a little lost there. So
yeah, so where's my little thingy? Annotate. Anyway, so on the, you find the derivative, right? So the derivative must be equal to the slope of the other line in order for them to be parallel. So that's what we set 2x equal to 2. So you solve for the x value that would make it true. So 1 will make it true. So if I plug in 1 into the derivative, you see how I get a slope of 2, right?
what true again?
They must have equal slopes to be parallel.
Yes.
Okay, so we found the slope to be 2 for the random line they gave us, right? So then the derivative must be equal to 2 as well for them to be parallel. So we want the tangent line to be parallel to this rando line. So we solve for x, we set them equal to each other here. When we solve for x, we find a value that will make it true. Make them have equal slopes. That would make the derivative equal to 2. So you plug in 1 there. That means that the tangent line will be 2, slope 2, just like this one.
So the x squared actually has nothing to do with this.
The x squared is the function, the original function. So if we graph the parabola and we graph the 2x minus 1, it's going to be right next to it at 1, 1. So it'll be the rate at 1, 1. Right, the derivative at f prime of 1 would be the rate at 1, 1. And the equation of the tangent line would be a line going right next to it or through it, like we did earlier. That's what we found. They just added another restriction. They said, okay, do what you did last time, but now I'm forcing you to make sure it's parallel to this other line, just cause. And then we had to do it. No rhyme or reason. We were forced to do this nonsense. Okay. The point of it was just to practice our line equations, reminding us of what slopes were, what does parallel mean, how do you find parallel lines, all that stuff was from long ago. So that's why they brought it up. Okay. Any other questions on these ideas? Thanks for hanging out with me on Valentine's Day, guys.
Happy Valentine's Day.
Happy Valentine's Day. Let's see here. Oh, sure, it might be empty in here today. All right, so this section is super chill, I promise. Let's see here. Looks stupid. Get rid of that one. Okay, let's start there. Save that. Okay, so look at number one, using the rules that we wrote down earlier. Those rules are actually more for 3.2, but I wanted to give them to you earlier so you can avoid some suffering. So number one, what is the derivative of negative 13?
Zero.
It's going to be 0 because why?
The constant rule?
Yeah.
First rule?
Yeah, it's the constant. It's a constant. It has no rate of change. Literally, it's constant. So it must be 0. It's not changing. So 1, 2, you see how they're 0, and that's why. Okay. Number 3 is a little more interesting. Let's do that one. Three 3.2. What is this section called? I don't even know what this is anymore. Basic differentiation. And rates of change. So I'm just gonna write it down real quick. If f is negative 13, f prime of 0, f prime is equal to 0 because it's constant. Constant. Yeah, I forgot what number we're doing. 3? I think. Yeah. Find f prime. I'm going to shorten the question because I'm getting lazier and lazier as time goes by. Find f prime. F is equal to 4th root of x. So we don't need any fancy rules, just the power rule. But we got to rewrite the question first, right? Do you remember what the square, I should say, what roots are written as in terms of powers? Sometimes, but what type of powers are there? Like, what is a square root as a power? Do you remember? It was this one might be further back in time. Nth root of x, so meaning it's some positive number that can always be rewritten as 1 over n power. So if you have a square root, that's a half power. If you have a 4th root, that would be a 4th power. Okay, you guys remember? It was a while ago. I think that one's like maybe late middle school, maybe. I don't know. I don't remember either. It's been a while. Another one you're going to need is the negative power. If you have a negative number on it, you remember you bring it down, right? Change the sign. If it's negative on the bottom, you just bring it up. You can actually move it up or down however you want. Just change the sign appropriately. So you can just bring it up, top, down, over and over again. Who cares? Up to you. Anyway, those will all be handy when you're doing derivatives, because you can't do the derivative straight up. You have to change it to a number because we know how to deal with the numbers, right? Just bring it in front and subtract 1. So the derivative will be 1/4. You bring down the 4th, subtract 1. What is a 4th minus 1? Negative 3/4. It'd be 1/4 minus 4 over 4. Which is negative 3 over 4. If you're wondering how that looks like, you gotta get a common denominator, right? Change the 1 to this. Okay, so now we have a negative power, so that means we could bring it down to the bottom. So that'll be 4x to the 3/4. Right? It's negative, bring it down. You could change it back to roots if you want to, but see how it's at the bottom, right? Any questions on example 2? Yeah, that's your derivative function. Quick note as well, some more algebra stuff. If you have a power, it's m over n. You could write that as the nth root of x to the m, or the nth root of x to the m. Technically, you could use either one you want. Either one is is okay. So you could rewrite this guy if you wanted to, but you don't have to. Just letting you know in case you need it. Okay. You never know what weird algebra rules pop up and they assume you remember everything. Okay, you guys cool? Number 2 then. Okay, let's do number 4. They're doing derivatives term by term. This one's a lot easier. Problem 4. Let's write the instructions. Find f prime again. I'm also going to use x instead of t. So f prime, all they want is the derivative. Bring down the 2. Bring down the 1. And then this will be a 0. So that'll be negative 12x plus 5x to the 0, which is negative 12x plus 5. That is f prime. Any questions on the power rule? That's what we did. 3.2 is getting comfortable with the power rule. Okay. Now let's mention the rules for sine, cosine, etc. That e to the x. You guys cool on this page? We'll also send you a sheet with all the derivative rules in one place, just in case. So if f is equal to sine, the derivative is cosine. If f is cosine, the derivative is negative sine. And you can prove this by using the limit rule. But I'm not going to make you do that. It takes fancy pre-calc. Sure, you guys can handle it though. Yes, negative sine. Negative sine x. Okay, f is tangent. Derivative is secant squared x. Isn't that cool? If it's secant, the derivative is secant x tangent x. If your function is cosecant, the derivative is negative cosecant cotangent. I forgot one. Cotan. Derivative will be negative cosecant squared x. Let's double check myself there because I'm getting pretty tired of doubting reality here. So derivatives. Basic. There we go. Those are hyperbolic. And here we go. I'll send you a sheet kind of like this, but with more stuff on it. Derivative of sine is cosine. Derivative of cosine is negative sine. Secant. Yeah, we're good. We're good. Got the exponential. This one's kind of cool. It's just itself. Doesn't change. Well, it kind of does, but it just ends up being itself. Here's a shortcut just in case you'll need this later. You have a number on the x. Let's say it's some k. The derivative would just be k times e to the kx, where k is a number, real number. And I'll send you a pretty sheet with all this stuff on it later. But we're gonna need this right now, so here you go. Okay. Look at the example. So here you go. Find the derivative of cosine and sine minus sine. You write this question down. Example 4. No. Yeah, 4 for 3.2. Well, I guess they call it y this time. Who cares? Okay, let's see. So find the derivative of y. Y is equal to pi thirds cosine minus sine. What is derivative cosine?
Negative sign.
So this would become 5/3 times negative sine minus derivative sine cosine, right? So we get negative 5/3 sine theta minus cosine theta.
So we leave the high third out of the whole thing.
Yeah, it's kind of like when we had the
Coefficient.
the coefficient thing. Yeah, same thing. Doesn't make a difference. So right here, derivative of 2 would be 0, right? Let me share that screen. Derivative of 2 will be 0. Derivative of sine is cosine, correct? So this will become 7 cosine. If you remember your rules, it comes straight out. Of course, I'm not going to force you to memorize them. Make sure those are on your formula sheet for test 2. All of the derivative stuff. Okay, let's do number 7. So derivative of e to the x is going to be itself, right? So it just stays like that. 4/7 e to the x. Derivative of cosine is negative sine. So this becomes so our answer is this guy. Any questions on 4 or 5? There was a 9? On the sign, right? Yeah. Right there. There you go. Okay. Any questions on these guys here?
So it's just break it down into little pieces.
Yeah, so it's one of the properties. When you do derivatives, do term by term. You'll be good. Some of the derivatives will require power rule. It may require you to rewrite them as a exponent, like the square roots. It may require you to remember or look up derivatives of sine, cosine, e to the x. Like all those could come up. But essentially, you're just doing it term by term and trying to figure out what function is it. If it's a simple power, cool. Do the power rule. Okay. let's look at the schedule. Question, what was it again? Sorry.
2.3, question 12.
Question 12. Find the limit.
It's the exponent on the sign that's messing me up. I don't know what to do with it.
Well, there's a few ways. Well, first of all, do you see what sign of the fourth means? Do you see what sign to the fourth means? We can test it out ourselves, I guess. For example, on a unit circle, let's see. Before we get to that problem, let's make sure we're comfortable with powers, right? So sine of 30 degrees is 1/2, right? So if I were to square the entire thing, let's say 4th power, right? It's going to square the output 1/2, sorry, 4th, 1/4 on the 1/2, which gives us 1/16. So I'm reading this sine to the 4th as 4th in the entire thing. Not on the argument. So different, because they would have said sine of 30 to the 4th, it wouldn't be 30 anymore, right? So what I'm seeing, what I'm seeing here, the limit as x goes to 0, or sine to the 4th, I'm understanding it this way. They're just writing it differently. Now, I'm also seeing that I can break this up and say, you know what? Here's 3 of them. Here's 1 more, right? Take the limit of each one separately. They're still got to be multiplied though. You see how this one will go to 1, right? This one will end up being sine of 0 times 1 once you take the limits. What is sine of 0? It's going to be So the y value would be 0 because it's on the x-axis. So if this unit circle starts here, goes around. So if this has to be 0, this becomes 0 times 1. Using your limit properties, because there's a limit property that says you can separate a factor and take the limit separately, but you have to multiply the limits together. So 1 times 0. That's why they got 0. That makes sense?
Yeah, just, yeah.
Yeah, it bugs me when they put the power right on the sign. I don't like that.
Let's screw up.
You have to like figure out what exactly does that mean, or what do you mean to look it up. Sometimes I forget to.
That was her moment.
What's that?
That was her moment.
Okay.
Are we done for that?
I mean, we actually stayed the whole time, so we're out of time. Sad.